Okay, so this first one, this is problem 1 on that practice test. So the first question is, how many real roots does f of x have? Well, we can start by just looking at the graph. How many times does it cross the x-axis? I see it once, twice. So that's how many real roots that it has. Now we need to figure out what are those. Let's just look. The one on the left, the one I just drew the arrow next to, that's at -5. So it has a real root at x equals -5. And then the other one is at x equals -2. So that's the one where I drew the star next to it. Okay, so that's how we can find what those real roots are. So now we want to know how many complex or imaginary roots does this have. Well, let's think about this. The highest power of f of x, I'm underlining right now in purple, it's x to the 4th. So that means it can have at most 4 roots. Okay? So if it has 2 real ones, that means it should have 2 imaginary roots as well. So I misspoke. So it should always have 4 roots, but at most it would have 2 real ones. But since we know we only have 2 real ones, that means we have 2 imaginary ones. And remember that these imaginary or complex roots always come in pairs, and they're always complex conjugates. So now we need to figure out what are these. So we're going to use our synthetic division to help find what these imaginary roots are. So we're going to start with, we have the root at -5. So we're going to use synthetic division to factor that out of our polynomial. So if we look back, we have 1x to the 4th and 12x to the 3rd. So 1, 12. We have 52x squared, 99x, and 70 is our constant. We bring that 1 down always. We always bring that first number down first. Multiply it by our box number. That gives us -5. Add those to 7. Multiply is -35. If we add those together, we get 17. Multiply that, we get -85. Add those, we get 14. Multiply, we get -70. That comes out to 0, so 0 is our remainder. That's good. That's what we wanted. So now we just double confirm that that's a real root. So now we're going to use synthetic division again, but this time we're going to use it with our -2. Okay? Let me put that up top. Okay? Now this time we had no remainder, so let's forget about that 0. Bring down the 1. Multiply by -2. Add them as 5. Multiply by -2 is -10. Add those as 7. Multiply by -2 is -14. Add, and look, we've got no root again, so that's a great sign. So we have left an x squared, because remember that's 2 less than our highest power since we did synthetic division twice, plus 5x plus 7. So now we're going to have to use the quadratic formula to solve this. So we're going to do -b is -5 plus or minus the square root b squared, which is 25, minus 4 times 1 is a, times c is 7, all over 2 times 1. Okay, let's simplify that inside. So we get 25 minus 4 times 7 is 28, so minus 28, all over 2. 25 minus 28 is -3, all over 2. Now a quick side note over here in orange, okay, the square root of -3 equals the square root of -1 times 3, and we can write that as the square root of -1 multiplied by the square root of 3. So thus we can pull out, because remember the square root of -1 equals I, so we can pull out that I. So this is going to equal -5 plus or minus the square root of 3 multiplied by I outside of that radical. So our 2 complex answers right now are going to be -5 plus root -3i all over 2 and -5 minus root 3i all over 2. So those are our answers that I just boxed in blue. Now in the next part, it asks us, what are all the roots? So now we just need to write all of those down. So I remember that we had negative 5, negative 2, negative 5 plus root 3, I outside the radical over 2, and our last one was negative 5 minus root 3, I all over 2. Now we need to write it as a product of linear factors. So I'm going to do that below. So our answer is going to be the opposite sign for all of those and put the x in front. So we're going to have x plus 5, x plus 2, x plus 5 plus root 3i over 2, and x plus 5 minus root 3i over 2. So that's our answer in pink and our answer above in brown.